Hi guys, back with me Aji Kurniawan Yusuf. So in this video, we're gonna talk about hypothesis testing. What is hypothesis? So hypothesis is derived from two words, hypo and thesis. Hypo means weak, while thesis means theory. It means hypothesis is weak theory or weak prediction. Since it is weak prediction or weak theory, we have to examine it. Therefore, we conduct hypothesis testing to know whether we should accept or reject the hypothesis. There are 6 common steps in hypothesis testing. The first step is state the null and alternate hypothesis. The null hypothesis is symbolized with HO, while for alternate hypothesis is symbolized with H1. The second step is determine the significance level or alpha. The third one is select the appropriate test statistics. The fourth step will be formulating decision rule. We need to determine the critical rule and the region in the graph. The fifth step is we take the sample and do relevant calculation, and the last step will be making decision and conclusion. So take a closer look at each one in more detail. We go to the first step first, state the null and alternate hypothesis. By the way guys, you have to be able to distinguish between research hypothesis and statistic hypothesis. Research hypothesis is the hypothesis that you will find in most of the research. It is the proposed answer based on the theory and real condition to your research question. The example of research hypothesis is the reward give positive effect on employees' performance. That is research hypothesis. Male have higher financial literacy than female. That is research hypothesis. While statistic hypothesis, it is mathematical statement tested by statistical data to explain about population. So, when you want to explain about population, you will conduct statistical analysis. Before you conduct statistical analysis, you need to create hypothesis. The mathematical statement of the hypothesis, that is statistics hypothesis. The example of statistic hypothesis is like this. The HO or null hypothesis is beta 0 equals to 0, while the alternate hypothesis or H1 is beta 0 is not equal with 0. Do you get the idea, right? What is the difference between research hypothesis and statistic hypothesis? Now let's go deeper to statistic hypothesis. How to create statistic hypothesis. So as I have mentioned previously, HO is the null hypothesis, while H1 or HA is the alternate hypothesis. HO and H1 are mutually exclusive and collectively exhaustive. Mutually exclusive means if HO is accepted, it is impossible for us to accept H1. If H1 is accepted, it is impossible for us to accept HO. So H1 and HO could not occur at the same time. While for collectively exhausted, there will be no other result outside than HO and H1. H1 is the opposite of HO. One more time, H1 is the opposite of HO. And this is the important thing, in the HO there has to be equality. One more time, in the HO there has to be equality. So the signs that could be put in the HO are equal, more than or equal, and less than or equal, because 3 of these contain equality. It is impossible for you to put more than into HO because there is no equality. It is impossible for you to put less than in HO because there is no equality. So, the signs that can be put in the HO are equal, more than or equal, less than or equal. Is it clear, right? While for the H1 or alternate hypothesis is the opposite. If the HO is equal, means H1 will be is not equal. This is the couple. If the HO is more than or equal, the H1 will be less than. If the HO is less than or equal, the H1 will be more than. It is easy, right? So we have three couples here. The first couple will be equal and is not equal. The second couple will be more than or equal and less than. The third couple will be less than or equal and more than. How to know which couple we should use? It depends on the question. These are the example. If the question contains larger than, larger is more than, right? It is the H1. It is impossible to put more than into HO because there is no equality. So the HO will be less than or equal. The H1 will be more than. If the question is smaller, smaller means less than. Less than is H1. The HO will be more than or equal. If the question is there differences? Difference means it's not equal. We can put is not equal in the H1. So the H1 is not equal. The HO will be equal. So how to know which couple you use? It depends on the question. This table provides you more detailed explanation about which couple you should use based on the keywords of the question. There are three common types of the graph. The first graph will be two-tailed. It means two sides will be shaded. The second one is one tail left. It means the left side, one side only is shaded. And the last one is one tail right. It means one tail only shaded, but it is in the right. For two-tail, it is used when the HO is equal and H1 is not equal. For one tail left, it can be used if the H1 is less than. Okay, you can see from the H1, yeah, if it is left, it is less than, so the HO will be its couple more than or equal. For this type, one side or one tail in the right, the H1 will be more than, so the HO will be less than or equal. Is it clear, right? So this is the example. Write the statistic hypothesis for these research questions. Use mu for representing population mean. The first question, can we conclude the mean of men's height is higher than that of women? So we want to compare the mean of men's height and also women's height. Okay? In the question, the keyword here is higher. Higher means more than. We should put more than in the H1. So the H1 will be mu man is more than mu woman. So the HO will be mu man is less than or equal mu woman. Next question. Is the average sales of manufacturer company equal to 3 million rupiah? The keywords here, equal. We should put equal in the HO. So the HO will be mu equal to 3 million rupiah. The H1 will be mu is not equal to 3 million rupiah. The next question. Is the average quantity sold of January is less than 100 units? The keywords here is less than. So less than, it is H1. That's correct. So H1 is mu is less than 100. So the HO will be mu is more than or equal to 100 units. Now we go to the second step, determining the significance level. Because you want to analyze the population, but you only take several samples to analyze, of course there will be errors that occur. Significance level or alpha is the acceptable level of error that the researcher is willing to tolerate in statistical tests. Usually, the common significance level will be 1%, 5%, or 10%. For the social science, 5% alpha is commonly used. While for finance research with secondary data, usually we use 1%, 5%, and 10% alpha. We have to be careful in determining the significance level or alpha. Why? If we choose too high or too low significance level, the effect will be the result of our analysis will not be the same with the reality. The third step is selecting appropriate test statistics. There are 4 common types of tests. The first one is C-test, the second one is T-test, the third one is F-test, and the last one is chi-square test. C-test is used if the sample size is large, usually if it is more than 30, and the population standard deviation is known. So you have to meet these 2 requirements. The first one is large sample size, more than 30, and population standard deviation is known. If at least one of the requirements is not met, then we should use T-test. This is the common test that we use. So T-test is used when the sample size is small, usually less than 30, or population standard deviation is unknown. So even though the sample size is more than 30, if the population standard deviation is unknown, you should conduct T-test. The next one is F-test. F-test is used to compare more than 2 populations. We use F-test to conduct analysis of variance or ANOVA. For chi-square test, it is used to compare 2 samples containing categorical variables. Now let's go to the fourth step. It is formulating decision rule, determining the critical value and the region in the graph. So this is the example of the graph. I take one tail graph right. The white area will be do not reject area. And the shaded area is the rejection area. This is the information that you have to know. The total area of this bell curve, so this graph, we call this as bell curve, is 100%. The area of the shaded area depends on the significance levels that you choose. If the significance level you choose is 5%, it means the shaded area will be 5%. So the white area will be 95%. Is it clear, right? This line between white and also shaded area we call as border line. If you use C-test, there will be C value. If you use T-test, there will be T value. The C value or T value in this borderline we call as C or T critical. C or T critical is C or T that exists in this borderline. In the fifth step later on, you need to conduct C or T calculation. If your C or T calculation is larger than critical, for example, your calculation is here, C or T calculation, so you need to reject its O, since it is in the rejection area. But if C or T calculation is here, you need to do not reject its O. You cannot say accept its O in statistics, but you have to say do not reject its O. Is it clear, right? So if C or T calculation is larger than C or T critical, you need to reject its O since it is in the rejection area. If C or T calculation is less than C or T critical, you need to not reject its O. The question is that how if it is one tail and negative? So you just compare the absolute value of C or T critical with C or T calculation. And the rule will be the same with this. Okay, so what you need to compare is the absolute value. Okay, not negative value. Is it clear, right? How about if it is two tail? To make you easier, just compare the C or T critical and C or T calculation in the right side. So you need to compare C or T critical in the absolute value with C or T calculation in absolute value. The fifth steps, you take the sample and do relevant calculation. There will be several formula of C calculation, T calculation, F calculation, and chi-square calculation. It will be explained in the material related to C, T, F, and chi-square. The last step will be make the decision and conclusion. There are two types of statistical conclusion. The first one is do not reject its O. As I mentioned previously, you cannot say accept its O, but you can only say do not reject its O. The second one is reject its O and accept its one. It is one unity. Don't only say reject its O. Don't only say accept its one, but you have to mention reject its O and accept its one. After that, you can create sentence based on the question, based on the conclusion that you make.